All right, thank you. Thanks, Jason, and thanks, Corey. Corey, that was an awesome talk. I don't know if he's in the audience right now. Probably not. We actually spoke right after each other at Nike less than a week ago, so this is the second time that we're doing this. I found his talk really interesting because, and it hit really close to home, because I have seen in an incident before someone been trying to find the answers. They are like, I know it's on this particular dashboard, and they're scrolling. Their scroll bar is the tiniest it can ever be, and they can't find it. And they spend 20 minutes trying to find it, and it's actually on the first page that they were on. And so that was a very interesting incident in that it took them 20 minutes to find something that they saw within 30 seconds, but didn't even realize they saw it. So today I'm going to be talking about before, during, and after chaos, the different phases of chaos engineering. And like Jason said, I gave a talk at Monitorama Baltimore, or Monitorama PDX a few months ago, and it was on the 8 different traps of chaos engineering. And so this is kind of a continuation of that talk, but I will give a quick overview as well. So chaos engineering is new, it's fun, it's exciting, but there has been so much focus on chaos engineering tools and all the ways that we can do chaos engineering safely and all the cool tools that we can use to break things in production. But today I want to focus specifically on the different phases of chaos engineering with a special focus on the before and the after phases, and not so much on the during phase. And the reason why is because that phase gets so much attention now. And there's plenty, if not more, insightful data to gather in these before and after phases. So chaos borrows ideas and theories from a bunch of different industries, and I think it's worth studying those more and bringing them into software. We don't have to reinvent the wheel. We can use things that other industries have done pretty well. And so these industries are resilience engineering, simulation performance, learning science, and game day type exercises that happen in other industries. So I'm Nora Jones. I've been involved in risk, operations, and reliability worlds for a while now, and I've had the privilege to practice chaos engineering at 3 incredibly different companies. I think I have the best job ever. I get the opportunity to connect the adaptive capacity of humans, the analysis of incidents and vulnerabilities, and organizational improvement through distributed systems, and then I also get to practice chaos engineering. I'm actively working and researching to connect and draw parallels between these 2 worlds right now, human factors and chaos engineering. I worked on the chaos engineering book with my colleagues at Netflix and learned a lot about what I think about chaos engineering today. And in 2017, I keynoted at AWS reInvent to help share what the business case was behind chaos engineering. So since then, I've seen a bunch of tools come out. We've seen different takes on how chaos engineering can be done to break things in production. And it sort of evolved my thinking into where it is today and where it's going. So just to set the tone, I'm not sure if everyone here has heard of or practiced chaos engineering before, so I want to give a quick definition. It's the discipline of experimenting on a distributed systems in order to build confidence in the system's capability to withstand turbulent conditions in production. This has been taken in a number of ways. It's been taken as injecting purposeful faults in production. It's been taken as breaking things, but really it's about exploring the chaos that's actually already inherent in your systems and surfacing it in a very scientific way. So to look forward and envision how organizations can kind of achieve high reliability and resilience, you first have to look back with unobscured hindsight bias. So the definition of a resilient organization is one that doesn't take past success as a reason to celebrate or a reason for confidence. They use it as an opportunity to dig deeper and find underlying risks. There's key components for chaos engineering beyond building platforms for testing resilience and running game days. It's understanding the concerns, the ideas, the mental models of how the system is structured for each individual at the company, and learning what your organization is good at in terms of resilience. So I will go into each of these 3 different phases. By optimizing for finding issues with chaos engineering before they become incidents, we miss out on getting the most of the point of chaos engineering, which is refining the mental models of our systems. So let's set some common ground before we go into the before phase. The goal of chaos engineering isn't to use or build tooling to stop issues, to find vulnerabilities for us. It's to build a culture of resilience to the unexpected. If tools can help with this, excellent, but don't forget about the main goal of chaos as you're building these tools. You know, that based on Corey's talk this morning and that story I was telling about the person that couldn't find that dashboard, if we could put someone in a situation where they even had to look for these dashboards, they could test those things before they were kind of in the heat of the moment. I want to share a quote from Sidney Decker, David Woods, and Dr. Richard Cook, who all study cognitive systems. And they say, resilience is not about reducing errors. It's about enhancing the positive capabilities of people and organizations that allow them to adapt effectively and safely under pressure. Chaos engineering is one means to help that enhancement. So now let's go into the before phase. So George Bach says all mental models are wrong, but some of them are useful. And I tend to agree with this. My mental model of the system is very different than my teammate's mental model of the system, who's very different than her teammate's mental model of the system. Each of your teammates on your team, even if you're on a team of 3 people, you all have different interpretations of how the system works and how the system fails. So I want to tell a story. I joined the Netflix chaos engineering team back in early 2017, and we were building some pretty cool stuff. We had built this system called CHAP. It stood for a Chaos Automation Platform, and it worked like this. It took advantage of the fact that all applications at the organization used a common set of Java libraries, and it annotated incoming request metadata that a particular call should be failed. This metadata was then passed through the system, as the call propagated through the system, we would use CHAP to look for that request metadata, see if it was noted as should fail or should add latency, and then calculate a percentage of traffic small enough to get a signal to where we could test that failure. So we would split that percentage of traffic in half. We would route a certain percentage into a baseline cluster, a certain percentage into a canary cluster, and with the canary cluster, we would either throw a random exception or we would add latency between the calls, and then we would monitor how they would do against each other. The hypothesis was always that we would be resilient to this failure or this additional latency, and then we were able to monitor it. So it was pretty awesome. It really was. They were working on it before I joined the organization, and I spent about 2 years working on it as well. And we had many organizations roll their own versions of this. We had many people talking about it in different papers, and we had vendors come out with tools. But after a while, we kind of like sat down and asked ourselves, you know, we are 4 deep backend devs on this team, and we were heads down coding all the time, and we were building this platform, but who was actually running experiments on them? I couldn't help but notice our specific team had this very unique but limited expertise about the entire system and its failure modes. And when we took a second to reflect, we noticed that it was mostly just us running these chaos experiments, not the rest of the organization, but mostly just the 4 devs on the team. So here we were so proud of this amazing technical feat we had accomplished. Like, we could safely fail and add latency to things in production. But what good is it if the only people that are using the tool are the 4 people that created it? Now, we would try to get people to run their own experiments and use this system, but honestly, it was quite a bit of work on top of a full-time day job of programming and building out the system to try to also convince people to design experiments, to work on them, to spend the day running them. And so what did we do? Well, we attempted to solve this in a very common software engineer way. Does anyone have guesses on what we did? Sorry? We wrote code. We tried to automate it, right? Like, if there's any problem in the world, you just sprinkle some time and programming on it and it goes away, right? Like, that's how life works, I think. And so we said, okay, we'll just make the experiments for them, not a problem. And I'm not here today to tell you about all the fancy technical work that we did to do this, although that was a lot of fun. I'm here to tell you how it didn't go as planned, as most automation projects go. Has anyone had an automation project that did go exactly as planned? So I spent a couple months, a quarter actually, designing and implementing an algorithm for what to work on. And so this is also obviously inherently biased and based on expertise about what to experiment on and what data is important to decide if a particular piece of the system is safe to fail. So we had to collect various information about services from a ton of different sources in order to do this. We had to collect information about timeouts and retries and fallback and percentage traffic it served and all this other information about the service that would give us enough confidence to say, okay, this is safe to create and run a chaos experiment on. Now, a lot of the information we had to collect was either in like random config files, it was in dashboards, it was in the heads of like 1 or 2 engineers that had very special expertise in this. And so we had to interview a lot of folks to see how they thought of coming up with experiments. And it turns out all this expertise was in a lot of different places. After doing all this interviews and aggregating all this data, now I was the one with this very new and strange expertise, and I really didn't want it. Why was all this data not in one place? Surely it would be helpful for people, not just me automating these chaos experiments. So as a side effect, we did what Corey told us to do, and we made a dashboard. And so this particular dashboard was not actually our main goal of chaos engineering. It was a nice side effect that happened as a result. So I was gathering all this information about whether a service was safe to fail and if it had any known impacts and if it's had circuit breaker wrappers, if there were any fallbacks in place. I was collecting all this information and all of it, again, was scattered. And so I just decided, okay, since I have all of it now, I'm going to put it up in one place for people to see if it's useful. And it was. It was more useful than the creating and the running experiments. And so all this necessary data here was available somewhere in the system. It just hadn't been organized and represented to capture these patterns. People instead had to read and integrate each individual piece of the system to make an overall assessment. And there was really no reason to ever do this, so people mostly didn't. This UI was a direct result of going through the preparation for automating chaos experiments, and it ended up being more enlightening than running the experiments themselves. And the funniest part was at that time, we left the automation on for about 2 weeks before realizing that this was most of the value, and then we just ended up turning it off. We were able to get most of the insight just from this dashboard alone. Gary Klein is a cognitive psychologist, and in his world, he says, we can see pattern recognition as a primary means to distill expertise. And here we were able to recognize patterns more. So I started coming to this conclusion that some of the most insightful parts of doing chaos engineering experiment is not running the experiment itself and looking at it, but it's the process of designing it. Yet we don't spend much time talking about this part or the people involved in these experiments, their fears about the system and the failures, but that is data that actually needs to be collected, and it's really useful in terms of improvement in our organizations. So how do we design a meaningful experiment? Well, we want to focus on the who, the what, the why, the how, and that's something that needs to be collaborative. It sounds like it could be elaborate, and it absolutely can be, but that's also how that you get the most value out of it. Discovering various vulnerabilities in poorly defined areas can take a lot of work. If I asked you if a very specific piece of your system failed tomorrow, would you know who to call? We all have that piece of our system and our organizations that, maybe Karen ran 5 years ago and she's not at the organization anymore, and we're kind of all crossing our fingers that hopefully it's not going to fail in a while, but we still have a few users using that particular thing. That happens everywhere. But would you know who to call, and would you know where to look in that particular situation? So if we're running a game day type scenario, we want to pick a facilitator. This person should be guiding the experiment and pushing the teams involved in different directions. They should not be the person designing it. Ideally, it should be a third party. They should be a person with respect and clout in the organization that can help try to remove all biases if possible. So they want to help ask the teams, what do we want to experiment on? And they want to involve all people participating in the experiment in preparation. Right? They want to involve all the people on the team, some of the sub-teams, which is what takes a lot of time and you can get pushback on. And sometimes it's even helpful to to interview people one-on-one to understand their fears of the system, what keeps them up at night, what they're on call for, and what they don't understand very well. I want to share a quick story about the Apollo 1 launch rehearsal test. It was the first crewed mission of the United States Apollo program, and it was the first project to land the first men on the moon. And so they had a launch rehearsal test where a cabin fire actually broke out and killed all 3 crew members. And during the launch rehearsal test, beforehand, they did not notify all the necessary parties in the design of the experiment, like the rescue team or the assistance or the medical assistance team. Because it was just an experiment, they didn't need to notify these people. I've seen chaos experiments go similar ways where someone doesn't notify the ops team or the on-call, and people are fumbling around trying to figure out what's going on. Back to quoting Gary Klein again, he also has this notion of novices versus experts. He says the new employee can see times when the system broke down, but not the times that it worked. Now, if we include new employees in these experiments and we include more tenured employees in the experiments, we can also start to see the mental models and gaps, and new employees can actually ramp up quicker. And I want to add that as opposed to novices, experts can see what is not there. When you include both in your experiments, you also need to make it psychologically safe for the new employees to participate. Make sure they're comfortable asking questions, and sometimes you might need to do this beforehand in a private setting to unearth some of that data beforehand. So another way you can start designing chaos experiments is by looking at your incident data and making some observations. Now, if your incident data resembles the following, which a lot of organizations do, like MTTR, MTTD, MTTA, date, time, pager ID, severity. This is not going to help you in designing a chaos experiment or understanding how you're doing. You're going to want to spend some time gathering more meaningful data that helps you understand where the gaps are. And so here's some examples of meaningful data that can help you design an experiment. You could see which systems haven't failed in a while, which ones had failures that took us by surprise, which ones involved unowned systems, or ones that we actually had to call someone in that wasn't explicitly on call, and which ones involved people that had not worked together much before. Maybe they had systems that talked to each other, but they never really need to talk to each other. What did recent near misses look like, and which incidents involved difficulties in figuring out what was even going on. So that goes back to Corey's talk this morning too, is how do we figure out what's going on? So this is all stuff that you can quantify and put as part of your incidents, and it doesn't stop here. This isn't something that you just lift and shift to every organization. This is very org dependent. So how teams decide what to experiment on is also just as revealing as the incident itself, which is why it's important to have a third-party facilitator. They can find what is so revealing about what they want to experiment on. Maybe their Redis is keeping them up at night. Maybe they're using console in a really weird way. Those kinds of things are very revealing on their own. So once all of these questions are answered and all the roles in place, the designer and facilitator should share their understanding of the experiment and what was discussed and learned in the planning meeting for the rest of the group to consume in an easy format, and then share it with them and invite them to collaborate. So you want to discuss scope as well. How do you define a normal or a good operation? How are we establishing the scope? So where are we injecting the failure of the experiment? And does everyone in the room know the reasoning behind these things? It should not just fall on one person, the expert of the system. It should involve everybody. What do we expect from individual components? What do we expect from the system as a whole? Observability is feedback that provides us insight into a process and refers to the work needed to extract meaning for the available data. So with this in mind, how are we actually observing our system during failure? We also want to talk about how are we limiting the blast radius. So how do we know that the failure isn't going to go off the rails? How is it going to stop at any point? And we want to talk about what the perceived business value is to the service team, and if it's different than the perceived business value to the rest of the organization. And then we want to hypothesize. We want to take some time to formulate and restate our collective hypotheses of the experiment. If we fail X part of the system, then Y will happen and the impact will be Z. So now that we have some of the planning in place, let's head over to the during phase of the experiment. We've involved every party at this point. We know what to do in case of a fallout. It's time to move forward. And I want to share a quick story about one of the first times I ever got into chaos engineering. The tool I had written took down all of QA in the organization. We were going through a phase in this organization where we had had a ton of incidents recently. We were having them all the time. We were all getting called in on Saturdays, and we were kind of desperate at this point to figure out something to do to help us. And so my manager had asked me to start looking into chaos engineering. I started out with a very simple tool, and I started it out in QA. And I started emailing people. I said, here are the services eligible to participate. Let me know if there are any problems. I didn't get any messages back really, like maybe one or two that said, cool, good work. And so I waited about 2 weeks. I still hadn't heard anything. I went up to people at their desks. I was asking them, hey, your service is eligible for chaos. Here's what's going on. And they're like, yeah, sure, it's fine. And so assumed silence implied consent there, and we went forward, except it ended up taking down QA. And so we got a lot of pings after that, right? And it wasn't me that took down all of QA. It wasn't the tool that took down all of QA. There was a big communication and design phase here that didn't have the scientific rigor in it. And so we learned a lot about our system from this experiment, but we also learned a lot about how to do chaos engineering more effectively. So at Netflix, they spent a lot of time looking at KPIs during the experiment as well. And so I was talking before about the baseline and canary clusters. During experiments, they would add key business metrics like streams per second and downloads per second, and they would see the baseline versus canary clusters, and the expectation was they wouldn't deviate too much. And if they did deviate too much, like the one you can see in the bottom right or the one in the bottom left, the experiment would automatically fail, and everyone would be routed back to the main cluster with just a blip. And so if you worked at an e-commerce company, maybe some of your key KPIs are add to cart or checkout. And so those are things, even if you're experimenting on some very obscure place in the system far away from your key business metrics, you still want to keep a good eye on them. So some roles if you're doing a game day type experiment. You want to have a designer, so this is the person leading the discussion. A facilitator, someone that's keeping the group on track. Commander, someone that's actually sitting at their computer and executing the commands. You'll want to have a scribe, and this is someone that takes notes in a communication tool such as Slack or Google Docs on what's occurring in the room. You'll want to have an observer that is actually looking at and sharing all the relevant graphs and alerts with the rest of the room. And then you'll want to have a corresponder, someone that's keeping an eye on an ops type channel or corresponding with the on-calls about what, and is aware of what to expect and is able to communicate with them. So I want to share the definition of steady state from the principles of chaos.org. It says, start by defining steady state as some measurable output of a system that indicates normal behavior. So you want to know what your normal behavior is, and you want to know how much you're deviating from that. But you don't want to be lenient about the definition of steady state. And I want to go back to that Apollo 1 launch rehearsal test. So the morning of the test, the crew had suited up and detected a foul odor in the breathing oxygen. This took about an hour to fix, and then the communication system acted up. And shouting through the noise, Grissom vented, "How are we going to get to the moon if we cannot talk between 2 or 3 buildings?" So the steady state in this situation was arguably, it wasn't steady, right? And so we can kind of spend a lot of time preparing for this experiment. Maybe it's really hard to get on certain people's calendars. Maybe there's a principal engineer we really want to be in the room that is in meetings a lot. And so we get to the day, and maybe there's an incident that occurred in the morning. And it was a bad one, and everything's kind of fine now, but people are kind of feeling rocky. We probably don't want to run the chaos experiment in that case. And it can be really hard to say no, especially when you've done all this prep work for it. But this is a very, very good thing to keep in mind. So now let's go to the after phase. John Alspaugh says that resilience is the story of the outage that never happened. But I say, if resilience is the story of the outage that never happened, what story are you telling and who is actually there to hear it? Because if not, you're not actually building resilience if you're not sharing these stories and building them up. What good are chaos experiments if the only knowledge gained is from those running the game day? Are you actually measuring who reads and hears and acts on the information from the chaos stories? Who's reading the reports? That's how you know you're successful. It's a very tricky part of chaos engineering, and it involves a lot of work because you want to make it a story that people actually want to listen to. You can build an internal brand around the storytelling. You can call it something. The word chaos engineering helps with that for sure, and it gets people to read the reports. And asking questions after the experiments themselves are going to lead to better stories. You want to forget templates. You don't want to fill in something with a timeline and, cause and stuff like that. You want to ask specific questions, and here are some. You want to ask, what did you experiment on? Why'd you experiment on it? What were some of the reactions? How did people feel about experimenting on this particular thing? That's pretty revealing. What mental models got recalibrated? Who learned something that they didn't know before? Who was in there that had a very particular expertise and now has an expanded expertise? What was surprising to people and what was new? Who was present? This is really revealing as well. You can record things like their tenure, what team they were on, if they're a manager, if they're an engineer. How did we assess ourselves on how we did? Yeah, maybe the chaos experiment didn't bring down production, but how did we actually do here? What are the relationships between the people that were in the room? Do they normally work together? When was the last time they worked together in an incident? Did the system gracefully degrade or collapse at any point? And what were the necessary adaptations? And this last one I added in during Corey's talk is, how long did it take to find the right graphs? How long did it take to find the right metrics? Sidney Dekker says, looking at what went right, he says, the pursuit of success, what did we learn we're really good at? And so I adapted that and I said, look at what went right in a chaos experiment in order to help us understand what went wrong. Bridging chaos and resilience. We should focus more on what we learned we're good at, not just finding vulnerabilities. What did we learn we did a really good job at? And we can leverage chaos engineering to measure sources of resilience and create feedback loops that enhance it, and enhance the organization's ability to monitor and revise our mental models, target specific safety investments, and the most important one, build expertise. These things can be used as a cultural artifact. My friend Mike McGarr talks a lot about cultural artifacts in an organization and how they give you a sense of how the organization is actually operating and running. These reports can be used as an cultural artifact, much like after incident reports. Imagine giving these things to a new hire when they started. They learn how people work together pretty quickly if they're done well. It's okay if these reports don't have action items or bring change right away. It's something that's going to happen over time. The facilitator in these experiments is not a rule enforcer to make sure people are doing things afterwards. They're there to help disseminate expertise. This is not learning. You don't want to structure your ROI of chaos because we now have less incidents in May and maybe we started chaos engineering in April. This is bad. Don't do this. You can't actually correlate these two things together. There's no possible way to attribute reduction of incident count to chaos engineering experiments. This is a cheeky illustrative book that was written by Darrell Huff in the 1950s, and it still holds up really well. It is very easy to lie with statistics. It's easy to lie to ourselves and figure out how we're doing just based on certain things that we're measuring. It illustrates outlining errors when it comes to the interpretation of statistics and how these errors may create incorrect conclusions that lead us to believe we're performing differently than we actually are. And so some key takeaways from creating Foresight with chaos is you cannot shortcut some of the work involved here. Safety should not just fall on an ops or reliability team. It should involve everybody. Don't give new employees vulnerabilities to go through and fix when they just join the organization. Give them reports to look at and learn from. You want to use write-ups as learning opportunities, and you want to connect all these phases of chaos so that you're building an actual feedback cycle and not just building tools. Thank you.
Thank you, Nora. Before we head in the break, any questions for Nora? Got time for one or two? Do we have one? Oh, yes, sorry.
I just thought your last one was very interesting. I'm someone that has to hire people, bringing people up to speed is important. And you're right, the first thing that happens is go over and fix this bug.
Yeah.
You're saying there should be things like postmortems and so forth. Can you expand a little bit on that?
Yeah.
Can you repeat the question?
Yeah, so the question was, this came from someone that manages a team, and he said a common way of ramping people up is go over and fix this bug, right? And he was saying in my last point, I was saying to not have them do those sorts of things. So what I've seen in the past before is we'll run a chaos experiment either automatically for them or a game day will get run, and the vulnerabilities never really get fixed, and they kind of just sit on a backlog for a while, but people kind of feel like they have to, okay, we found that this timeout was too high, or we found that this service wasn't executing in the right way. And so what I've seen sometimes is that managers will say, oh, great, we have a new employee on the team. This is the best way to get them ramped up. We'll have them fix these vulnerabilities. But the vulnerabilities that happen as a result of chaos experiments or incidents represent gaps in mental models of the system. And so by giving them to a new employee who doesn't have a fully formed mental model of the system, you're not actually understanding the vulnerabilities and the bugs very well. And so while it is an interesting way for the new employee to get ramped up, it's not awesome in helping disseminate that expertise. It should usually be done by someone that's more tenured on the team. That's it. Any other questions? Sure.
So when you're trying to ramp up resiliency, chaos in an organization that may or may not be on the fence about that, or they might just want to buy a tool to fix that,
Yeah.
what advocacy or engagement processes do you use to actually get them on board with saying this is going to take time?
Yeah.
You can't fill it with a tool. You can't just go straight to running tests in production or even in SAT and consider it okay.
Yeah.
So what do you find? What do you think is effective?
In terms of getting buy-in?
Yeah.
Yeah, it's a really good question, and so I've had to do this in very different ways in the 3 organizations I was in, and it's super org dependent. One thing that has worked for me really well though is to find a team that's very well respected in the organization. Now they may not be someone that needs chaos engineering and needs resilience tools as much as the rest, but if you can get them excited about that and just use them as a case study for a while and just go deep with them and then share it with the rest of the organizational world, people tend to want to copy what those teams are doing. They use them as examples, they're role models, and that has normally worked for me in the past. Also just spending time with that team and just spending a lot of time on the stories, having them be advocates as well. I mean, you really are an internal salesperson in your organization, so it's important for that person to have some credibility in the organization as well, and just be comfortable going to teams and talking to people. Mm-hmm.
Actually, I think we're going to have to cut it.
I'll be around.
Yeah, thank you. Is this your little?
No.
Okay. Again, we have the talk channels. Thank you again, Nora. Another round of applause, please.